All right, now this is the first example on chord properties. I don't know, maybe I forgot to mention that what I just explained to you now is called chord properties. All right, that's where we start from when we're dealing with circle theorem. Now, this very simple example says a chord is 8 centimeters from the center of the circle of radius 17 centimeters. Find the length of the chord. Very simple question. Your first step, just draw the diagram because it mentions a circle, center of the circle. Okay? Now let's take it step by step. A chord is 8 centimeters from the center of the circle. So there is a circle, there is a chord, AB. Length AB is the chord. Now it says that this chord the distance between this chord and the center of the circle is 8 centimeters. So when it uses that term, 8 centimeters from, it means the distance between the chord and the center of the circle is 8 centimeters. So that line that connects the chord and the center of the circle, the line measures 8 centimeters. So we brought out one part now. It now says, it says from the center of the circle of radius 17 centimeters. So the radius. Now, you're not going to come now just because they mentioned radius. You have your chord here, you have the center of the circle here. And then they say radius 17 centimeters. Then you now come and draw the radius from here to here. No, you are going off. So you need to make a logical diagram. So that radius, where do you draw that radius to get to that it can have a logical diagram? Is if you draw it from here to this point, all right, of the circumference where it touches both the circumference and the tip of the chord, and from here to this point. So you see, you can make a logical diagram out of that question now. We know that from here to this place is also radius, but it doesn't make any sense to take it up to that part. You have to make a diagram that makes sense. So in this case, it says that the radius is 17 cm. So we draw that radius from here to here, from here to here, to just indicate that we've drawn the radius of 17 centimeters. Then the question is, find the length of the chord. So you have drawn that line, the distance from the center to the chord, 8 centimeters. You've drawn the radius here, and you also drew this one from here to here. So they now said, find the length of this chord. So what is this measurement from here to this place? Very simple question. So what do you do? Now, looking at your diagram, as you can see, these are two triangles, two separate triangles, but they are the same, the same measurement. They are the same triangles. You remember the proof I showed you earlier. So how can we solve this problem? How can we find the length of AB, that is this chord? So what I'm going to do, I'm going to bring out these two diagrams. I'm going to bring it out onto my rough work, okay? Or even my main solution. So I'm picking out this first triangle and I'm picking out the second one. I've not changed anything. I just want to bring it out clearer so that I can see things clearly. So this is 17, this is 8, this is 17, and this is 8, just as we can see here. Nothing changes, all right? Remember that this line is common. Good. So what is it about this particular triangle that is interesting? It is a right-angled triangle. That is, a triangle that has angle 90 degrees as one of its angles is called a right-angled triangle. So what is special about a right-angled triangle? Now, a right-angled triangle can be used to solve for different things. You can solve trigonometry there, where you have your SOHCAHTOA. I believe you've heard that before. And you can also use it to solve Pythagoras' theorem. Now, Pythagoras' theorem is a very simple theorem that I know you remember very well. So what does Pythagoras' theorem state? So Pythagoras' theorem, it deals with only right-angled triangles. So for example, this is a right-angled triangle, okay? Now, in Pythagoras' theorem, it says that this right-angled triangle has its longest side called the hypotenuse. And then the side that is opposite the hypotenuse is called the opposite. And the side that is right below the opposite and the hypotenuse is called the adjacent. Sometimes they give you another included angle here, and when they give you this included angle, it makes it even easier to know which side is the opposite and which side is the adjacent. But in all cases, the hypotenuse is always the same, the longest side. Now, the side that is facing that included angle is always known as the opposite. And the side below the right angle and the included angle is always called the adjacent. So no matter how they draw this diagram, okay, no matter how this diagram is drawn, you should be able to identify the opposite, the hypotenuse, the adjacent. Okay, let's say this is my right angle here, and I put the included angle here. How do I know which side is my opposite? Now, the side that is facing the included angle, that is opposite the included angle, is always opposite. The side beneath the right angle and the included angle is always adjacent. And the longest side is always the hypotenuse. So don't ever forget this, all right? Now let's come back to our solution. So here, I want to find the length of this line to this line, but I know that this line here has divided this chord into two equal parts. So if I can solve for only this one, automatically I will get the answer of the entire chord. All I need to do is I will just let's assume that the answer to this one was 2. All I would need to say is now 2 plus 2, which is 4. That means the length of the chord will be 4. That's just an assumption. So all I need to do is I'll just solve for one of the triangles, and whatever answer I get for this side, just multiply it by 2, and then you get the length of the entire chord. So let's solve for this one, okay? Now we're looking for this side, and what side is this? We're looking for the adjacent side, okay? Now Pythagoras' rule states that when you're given a right angle triangle, the hypotenuse, the opposite, and the adjacent, it is usually a squared plus b squared equals c squared, okay? This a squared means the opposite side plus b squared, which is the adjacent side, and equal to the hypotenuse squared, that is c squared over here, okay? So basically that means the square of this side plus the square of this side must be equal to the square of this side to satisfy the Pythagoras rule. So let's now fix it. So let this unknown here, let's call it x. That is x squared plus the opposite, which is 8 squared, equals the hypotenuse, which is what? 17 squared. Very simple. So what do I do? What is 8 squared? 8 squared is 64. 17 squared is 289. So what does that mean? I'm going to take my plus 864, and I'm going to bring it over here so that my x squared can stand alone, because it's x I'm looking for. So I'll make it the subject of the equation. So I have my x squared equals 289 minus 64, because 17 squared is 289. So 289 minus 64 is going to give me 225. Now, I'm looking for x. I'm not looking for x squared. That means I have to get rid of this squared, but I have to do it properly so that I don't do the wrong thing. So when squared jumps over the equality sign, it becomes the square root. So that means x equals the square root of 225. So x is equal to 15. The square root of 225 is 15. So which means this side is 15. So if this side is 15, automatically this place must be 15. So you can see here is 15, here is 15. That means the length of this chord is simply 15 plus 15, which is 30. Or you can say 2 times 15, which gives us 30 centimeters. So the length of the chord is 30 centimeters. Now, I want you to study this example, and then I want you to try this out, okay? So I'm going to give you a hint on how you could do this. It says the radius of a circle is 13 centimeters. First, you have to draw a circle. Now, a chord of the circle is 24 meters long, 24 centimeters long. Good. So when you draw the circle, you draw a chord, just like you have this chord, but this time around, they give you what the chord is, which is 24. Now the next step is calculate the distance of the midpoint of the chord from the center of the circle. So when you draw that diagram, this time around, you'll be calculating this line in the diagram for this question. So your radius is 13 centimeter. You have it here, 13 centimeter. And then you have this 24. But let me give you a hint. Since there is a line that divides that chord, you're going to divide that 24 into 2. So have one side each 12. I don't want to draw the diagram. I'm just giving you hints that could help you solve it. So let me leave it at that. All right. So let's see. Once you solve it, snap it and send to me. If you have any challenge, just beep me.